everybody, my name is Terry and I've just finished restoring this beautiful Honda CB750K, a 1980 bike that you can see behind me. Or I thought I finished restoring it. But yesterday I was just cutting around the local city, getting film from my wife's car so I can send a nice video to the customer so that he knows that everything's all right. When we stopped to take the camera off so that I could then stow it and ride away, the bike was really reluctant to start. It's not an engine issue, it's the battery. The battery was almost flat. So clearly the battery is not charging. Thankfully, after waiting and letting the battery recover for a few seconds, I turned it over, she fired into life, and I rode straight home. So when I got back last night, I connected the Optimate charger here. And normally when I've connected this bike up in the past, what's happened is it will very briefly flash the recover sign here for about half a second, then it'll go to charge, and then normally after about 30 seconds to a minute it will move from charge to maintain. And what that's telling me is the Optimate's looking at the batteries going, hello, what's going on here? Oh, actually you're quite good, a little bit of charge, now you're fully charged again within a minute, and now I'm just going to maintain you. And then if you leave it on for a while, it then makes an assessment whether the battery is weak or strong. Now when I connected this after yesterday's disastrous ride, it went into recover mode, and it stayed in recover mode for a very long time. Don't know how long exactly, but I think there's something like 30 minutes to an hour. It then moved to charge mode, and it was in charge for hours, 2 to 3 hours. And then it switched to maintain, and eventually, sometime overnight, while I was tucked up in my scratcher, we've got strong back here. So what I think that's telling me is that the battery itself is okay. It's just that we ran it down by riding the bike, and there's something wrong with the charging system. All right, now the charging system worked perfectly well before, so what's happened since then? Well, the only thing that I have physically changed is that I've put this battery charger lead on here, which the customer uses to keep his battery on because he works away from home a lot. And that just connects into the positive and the negative terminals there. So the first thing I'm going to do is just take that off to try and eliminate it as a source of the problem. If we then get deeper and the problem's still there and we end up going on and fixing something, then we'll know it wasn't that and we can put it back. But that was the last thing we did, so let's take it off. Now it's going to be much easier to work on the bike if it's upright. It's also easier if I can elevate it. It's not essential. Anything that I'm going to do here you could just do with the bike on its side stand, but it's just easier. So I'm going to put the bike on the hydraulic lift. That involves taking this old bike off there and swapping them around. And this Honda, it's so heavy that although I would normally always push a bike onto a hydraulic lift, this is so heavy I think I'll hurt my back if I do that. So I'm going to start it and then just run it up gently on the clutch. If you do that, you've got to be ever so careful, because if the bike gets away from you, it'd be a disaster, especially if it falls over while it's running. So when I do that, I've always got my hand on the clutch, obviously, and my thumb near this little red button here, so I can kill the engine very, very quickly if anything happens. And I always keep the weight towards me, because it's always easier to stop a bike falling over towards you than away from you. Anyway, the other thing that will allow me to do, because I'm going to start the engine, is it will get the engine nice and warm. Because if you're going to do electrical testing on the engine, so at some point we're going to start it and rev it and see what the charge current is. It's best to do that with a warm engine. So we're going to hit two birds with one stone, really. We're going to warm up the engine, we're going to get it on the hydraulic lift, and then we can get on with the work. Oh, and I forgot to mention, the weather today is terrible. It is actually snowing outside. Well, at least the bike won't overheat. It's really easy to get at the electrics on a CB750. We just need to take off the two side covers and the seat. So we'll do the right hand side cover first. Each side cover is just held on by 3 spigots which go into rubber sealed grommets. And then the seat, just one bolt, and then it will unhook off its hinge.
Once I've done that, then I'll be able to get off the left side cover as well. When the seat's on, it's quite difficult to undo the side cover on the left hand side. That's why it needs to come off. The bottom of the three spigots is missing off this side panel. It must have snapped off from a previous owner, but we're going to fix that before we put the bike back together. Now I want to eliminate this battery charging tender lead from our inquiries, so I'm going to disconnect it from the battery. That involves disconnecting both battery terminals because the lead is sort of sandwiched between the screw and the battery. I always take off the black lead first and then the red lead. If you do it the other way around and you accidentally touch the red lead against the frame, then you'll get a spark and you could potentially damage something. Don't worry if you get it wrong, you won't electrocute yourself, it'll just make you jump a little bit. And when you put the battery back on, then do it the other way around. So red on first and then black on second. So when I get the charger cable off, I'm having a good look at it, see if there's any breaks or damage on it which might cause a short. I will look at the fuse underneath that little cover there and look at those little eyelets that go on the battery. One of them is a little bit grubby actually, the one that goes onto the negative terminal. That might increase the resistance a little bit, but not really enough to stop a battery from charging. So I don't think this is the issue. And this particular cable is just to charge the battery when the bike's not running. It's nothing to do with the onboard charging system, it's just for convenience when the owner's away. So let's remove it and eliminate it from any further analysis. Now the next step before we do any kind of measurement with our multimeter is to plug in the battery charger and get the battery up to full charge again, so that we don't get any confusing readings. So I'm going to plug in my battery charger, I'm going to have a cup of tea and come back when it's fully charged.
And here we've got a multimeter. I'm not going to teach you how to use a multimeter, but I've got black lead in COM, I've got the red lead on this side, everything except current. And I'm going to switch it to volts. That's volts AC or DC, and then we use function to select auto ranging and DC. So the auto ranging means it's going to give us a sensible reading. So if it's really low, it's not going to try and fill the whole screen with noughts. And if it's really high, it's not going to strip off the important numbers. And DC there. If I keep pressing the function button, you see it goes AC, hertz, percentage. Now we're back to auto ranging and DC. All right, so let's just have a look, see what the battery's doing. As ever, you need three hands to do this. So we've got little protectors on the end of it. I forgot about that. Let's put them to one side. I've tested this multimeter, but this is the first time I've actually used it in anger. All right, 13.43 volts. That's saying. Just put that there, and then press the hold button, and that holds the reading. 13.43 volts. That's pretty good, I think. Right, let's see what happens when we idle the bike. Okay, back to cold. Let's start up with the choke on. Oh, I better put the fuel on. Where are we? There we are.
About 1000 or 1100 RPM, the charging system doesn't really produce enough to recover a battery. The battery will either slowly decay or just about hold level. So we're expecting to see something in the order of about 12 volts when we do this test.
Okay, now the bike's warmed up, and we're going to measure the volts at 3000, 5000 RPM.
When we rev up to 3000 RPM, the charging system should really get into its stride and should be producing 14.4 volts at the battery. When we run it up to 5000, we're checking that it doesn't go above 15 so that we're not overcharging it. should be getting 14.4 volts at 3000 RPM. We're getting nothing like that. So we'll disconnect the battery, and now we'll go to the next stage of the analysis. There are only 4 components of this system. The battery, which we already know is good, the connections, including the wires, the stator, and the regulator rectifier or reg-rec. So here I am tracing the cable that comes from the stator around to the other side of the bike and then connecting in eventually to the regulator rectifier. And here it is, my right hand's on it now. Now, rather confusingly, in the Honda manual, they call this the generator coupler, and the picture in my manual shows it on the other side of the bike. But this is definitely it. So let's disconnect it and take a look and make sure there are no problems with it. Looks okay, but I'm going to go in and clean each of the terminals with this little carb cleaning tool here, which you can scrape any dirt off with. And on the male side of the connector, which is a bit easier to access, I'm using some fine grit sandpaper to get rid of any deposits that's built up on them. And then simply reconnect, pushing it firmly home. So that was the connector between the stator, which should be generating the electricity, AC voltage, to the regulator rectifier. Next, I've disconnected the other coupler, and that goes from the regulator rectifier, which has turned that AC into DC voltage and is keeping it within narrow bands between 14.4 and 15 volts. So it's time to clean this one now. So a very simple system, an input and output from the regulator rectifier. So using the same technique, I'll clean this cable up and then reconnect it. So that's pretty much all we can do to make sure that the connections and the couplings are sound. The next thing is I'm going to reconnect the battery and we'll test it. But before we do that, there's one small test we can do, which is really, really simple, which is to make sure that the electromagnet in the stator is working properly. So to do this, we're going to get quite a thin feeler gauge, a 15,000th of an inch is pretty good, and just hold it near the stator, and it shouldn't attract it at all. But then when we switch the ignition on, it should act like a magnet, and see, that works perfectly. So now we'll test the bike, and hopefully we'll eliminate some of the things that aren't the problem. So we know the batteries are good, we know the connections are now good, and we know that the electromagnet in the stator works. So let's test it and see if we're getting any charging, having done that cleanup.
Just over 12, not good. Okay, next we're going to measure the DC voltage between the black and the white wire on the stator connector here. That should be close to battery voltage. So I'll measure this and then we'll check the battery voltage. We'll see if it's getting through. Okay, so the black is that one top left as I'm looking at it, and the white is bottom left, so it's the opposite ones where there's a gap in the middle. Yeah, let's measure the DC voltage there. Okay, 10.3. I'm going to try it one more time. And I'm going to press really quite hard on those things so we get the cleanest contact we can. Now, it doesn't matter what I do, it's about 10.3. Okay, that's telling us something. Now let's do the same test on the battery. And there we're getting 11.6. So 10.3 versus 11.6. Okay, I'm going to test the stator now. The stator's got 3 windings, and the windings each have a yellow lead coming off them, and what we're going to do is test the resistance between any 2 yellow leads. So we'll test the outside to the outside, then the outside to the inside, then the inside to the outside on that side. Now we don't test it here, of course, we've got to test it up here because that's the lead that's actually going to the stator. This is the one coming out from the reg-rec. Now the colours aren't so clear on here, but we can see that the 3 yellow ones are the 3 pins at the bottom, and then there's a gap for the top where you've got the power going, the power in the earth. So here's the 3 stator coils. So we'll start with the outside to the outside, and I put this on its side. I know it's difficult to read, but it's just easier for it to stand there. Ideally it should be between 0.4 and 0.5, but I think anything less than ohm is probably good enough. There you go. I think the better the connection you get, the lower the resistance there. So that's the outside to the outside. And let's check the inside to the outside on the left. Yeah, that's about 0.6. And then we'll test these two here. There we are, all about 0.6, which I think is close enough. So the stator windings are okay. Okay, next job is we'll have a look at the windings themselves and the brushes that take the power off, because if the brushes are worn down beyond the limit, that could be an issue. So these are just 8mm bolts.
Now I'm going to take the windings out of the stator cover so that I can take a good look around and make sure that the insulation around them hasn't broken down. And also I want to see the brushes inside, which are on that little black thing which is inset towards the end of the cap. So there are 3 bolts which hold the stator couplings in around the outside, and then there are 2 on that little black trapezoid shape that you can see at the bottom of the cap.
And that's going to come out. There we go. It's out. And here is our stator. There. Okay, so this has got wear lines on it. You see they go in and out like that. The wear line for that one is about 2mm above there. The wear line for that one is also about 2mm above there. It's just supposed to be shorter because it's contacting at a different place. Alright, so that looks like it's okay after all that.
So having satisfied ourselves that the stator works fine and the insulation hasn't broken down, we'll just put everything back together and put the cover back on.
One more quick test on the stator to make sure the insulation hasn't broken down. I'm just going to go and test between each of the yellow leads and the frame of the bike to make sure there's no continuity. So that's reading open line, and I just want to make sure if I touch it on an unpainted part of the bike, that will do there, that it stays open line. Let's check the next one. Open line. So now we know that the stator's not shorting out anywhere because the insulation's broken down. Good, that's fine. Okay, for the next test, we're going to check the output of the stator when the bike's running. I'm just going to do this at idle. You could rev it up as well, but as long as I get about 25 volts or so at idle, I'll be happy. And so we take the lead that's coming from the stator, which is this one. And we are going to go onto the yellow leads with the probes, and we've got it set to alternating current. The battery is reconnected, and so the bike will be running off the battery alone. The battery won't be charging, but we're just going to be seeing by going to each of these 2 connectors here how much AC we're getting. So let's start the bike. And that's fine. once the bike settled down, it was making about 24-25 volts across all of the connections. So I'm really happy now that the stator's working properly, which really means that the issue's almost certainly in the reg rec. So for the next bit of the test, I'm going to take the wiring that's going out of the regulator rectifier, which is this one, and I'm going to test the continuity between that and what's going into it from the stator. So the stator puts alternating current in, and the regulator rectifier should put regulated and rectified direct current out. So a simple input-output system. Let's disconnect the reg rec. There we go. So this is the one, and the two wires we're going to be going for are the red and white and the green, and I'm going to be bridging them across to the yellows. Now I've got the Honda manual here, and it says there are two sets of readings in the normal direction and in the reverse direction, and what that's doing is it's testing the diodes in there to make sure that current has got enormous resistance in one way, so it won't go through, and it's got very little resistance in another. So what we're looking for in the normal direction between the green and any of the yellows in here, then we should get between 5 and 40 ohms. So let's try that now. So
now you remember that I said earlier in the video there are only 4 elements to this system: the battery, the connections, including the cable connectors and the wires, the stator and the reg rec. Now we've effectively eliminated problems in the first 3 things on that list, so all the evidence at the moment is pointing towards the reg rec being the thing that's at fault. And when I test this, I don't get the resistance readings that I'm expecting between any of the cables that I connect. It does show me that the diodes are preventing flow in one direction, but the resistance where the current should be flowing is much lower than what I'm expecting from the Honda manual. So this pretty much confirms that the reg rec is the issue and we need to replace it. And so I set about ordering a new one. Now the original equipment manufacturer Honda part is not made anymore, but there are plenty of aftermarket parts. You can pick them up for about £85 to £110, and so you get a brand new aftermarket reg rec. Alternatively, you could do or consider at least what I do normally, which is to look at the scrappies. And I've had very good experiences with scrappies. They normally send what you order a day or two after you've paid for it. They're pulling it off a crashed bike, and so long as it's not been a component that would be affected by a crash, and a reg rec's pretty safe tucked away in the frame there, then you can get an original equipment manufacturer part for a fraction of the price of even a new aftermarket part. And that is indeed what I did. So I got a new reg rec. I got one for 30 quid for a scrappy, and it turned up 48 hours after I paid for it. So let's get the old reg rec off. First of all, we'll undo the 2 connectors, the one to the stator and then the one that comes out of the reg rec and goes to the battery. These are the ones that we've been testing, so we're quite familiar with these. Once we've taken those off, then we'll see that the reg rec is held on by 2 nuts on the end of long bolts, and they also serve to hold on brackets, the one on the right for a load of connectors and the one on the left for what I think is probably the main starter relay. So we'll undo those, move them out of the way, and then just pull the reg rec off, and that's it, easy. So here's the replacement reg rec, which I got from a scrapyard. All scrapyards these days put their stuff on eBay, by the way. You don't have to go rooting around a dirty old scrapyard in order to find things. It's all very modern. So first of all, I'm just going to unwrap it, take a look at it and compare it to the old one, and just make sure that all of the dimensions and the connectors look the same, and indeed they do. Now I'll simply bolt the replacement reg rec into place, put the brackets back on, tighten the nuts down and do up the 2 connectors. Simples.
Nice. Okay, side panels back on. These side panels are quite fragile, by the way. You can see a previous owner's put a repair on here, which I'm leaving well alone. And this bit was snapped off completely, so I've just put an old bit of plastic on there and used some baking soda and super glue. And that's got really quite good now. And it fits perfectly into that little rubber grommet there. So let's button that up. Done. I declare this bike fixed.
So there we go. Hope you found that useful, how to diagnose and hopefully fix charging issues with the Honda CB750. The techniques I used were a combination of what the Honda manual recommends and some techniques which I've picked up over the years working on other bikes. Please leave comments if you've got any top tips for me. Thanks for watching. See you next time and ride safely.